So from the following problem, we are giving a set, and then from that set, we're supposed to figure out which ones are natural numbers, whole numbers, integers, rational numbers, irrational numbers, real numbers, and undefined. So for part A, we are going to figure out which numbers from the set are supposed to be natural numbers. And so if we look at our set, we see a whole bunch of fractions, some square roots, pi, and some decimals, then 0 divided by 5, then 1 over 0. And so here we have the definition for natural numbers, and if you can see, a natural number is considered a number from 1 upwards, so 1, 2, 3, 4, 5, all the way up to infinity. So here we have, you can notice that there is no 0, we just start right off the bat at 1. So we have to look at our set and see which ones meet the criteria. So from the set, we can see that the only ones that meet the criteria are 14 over 2 and the square root of 64, where you might be wondering, well, why are those considered natural numbers? Well, 14 over 2 is actually 7, and the square root of 64 is 8. So therefore, they're considered natural numbers. And so now moving on to part B, now we have to figure out which ones are considered whole numbers. And so you can just ignore this and integers. We'll focus on that in the next problem. Well, a whole number is simply the number system 0, 1, 2, 3, 4, 5, and so on. So if you remember, natural numbers did not include 0, but whole numbers does include 0. There are still no fractions. There's still no fractions. And like, for example, 3.5, 1.1, and a half are not considered whole numbers. So if we look back at our number system, we can see that we have whole numbers now will be 0 and 14 over 2 and square root of 64. Well, you might be wondering, well, wait a minute. Aren't 14 over 2, can 14 over 2 and the square root of 64 be natural numbers and whole numbers? Yes, they can. And so here we have our whole numbers. Because again, 14 over 2 is 7, and square root of 64 is 8. Now we move on to the integers. And the integers are like whole numbers, but they also include the negative numbers. If you'll remember, whole numbers and natural numbers do not include negative numbers. But if you pay attention here, for integers, there are still no fractions allowed, and also decimals. So looking at our set from the original problem, you can see now that the integers will be negative 20, negative 1, 0, 14 over 2, and the square root of 64. Now, I hope you're noticing a pattern here, or some important properties. We have these three numbers. We have this one, who is a whole number and a natural number, as well as square root of 64. And now we have 0, which is a whole number and an integer. So we will tie all of that in at the end. And for D, now we're given the problem of rational numbers. A rational number can be made by dividing two integers. This is very important. They have to be divided by two integers. Here we can see a problem. 1.5 is equal to 3 over 2, because 3 divided by 2 will give us 1.5. And so you notice that when we divide two integers, we end up with a decimal. Now we have to be able to convert that decimal back into a fraction. That's what makes a rational number. And so here we have the formal definition of a rational number. A rational number is a number that can be in the form PQ, where P and Q are both integers, and Q is not equal to 0. Q is in the denominator, so that means the denominator can never be equal to 0. So looking at our set, now we have rational numbers. And so the rational numbers here will be negative 20, and negative 1, and 0, and 0.25, because 0.25 is equal to 1 over 4. And then we have 14 over 2. Then we have the square root of 64. And then we have 2 over 6, and 0 over 5. Now you must be wondering, like, wait a minute, But why are negative 20, negative 1, and 0 considered rational numbers? They're just numbers. Well, they have this funny little trick where we're supposed to remember that you can put 1 underneath everything. So negative 20 over 1, that's still a rational number. Negative 20 divided by 1, that still gives us negative 20. So the same thing with negative 1. Negative 1 over 1 is equal to negative 1. So this right here is still a rational number. 0 divided by anything is still 0. So 0 divided by 100 is still 0. So therefore it's a rational number. And square root of 64 again is equal to 8. So 8 divided by 1 is still 8. And 8 over 1, that's the rational form that's needed. Because 1 in each case is an integer. And so therefore that's why we end up with negative 20, negative 1, and 0, and square root of 64. That's how we end up with those in our rational number bubble. Now we have irrational numbers. Well, irrational numbers is a real number that cannot be written as a simple fraction. And so here, if you remember, we have a rational number. We have an integer in the top and an integer in the bottom. Great. But we have this decimal right here, 1.5. We were able to rewrite 1.5 into its fraction form. Now, if we give you pi, 3.14159, and so on and so on, they still haven't been able to figure out what the last digit of pi is. So therefore, it's irrational. We can't put pi into a fraction form. So with our set, the irrational numbers are negative square root of 3, square root of 19, and pi. You must be wondering, well, why wasn't square root of 64 an irrational number? It's also square root, just like negative square root of 3 and square root of 9. Well, square root of 64 gives us 8, so therefore this is not an irrational number. But negative square root of 3 and square root of 9 aren't perfect squares, so therefore they're irrational numbers. Next we have real numbers. And real numbers are just numbers like 1, 12.38, negative 0.865, 3 over 4, pi, 198. You know, almost any number you can think of is a real number. Which means almost any number. So real numbers include whole numbers, rational numbers, irrational numbers. So you may be wondering, well, can real numbers include everything? Well, almost everything, but they don't include undefined numbers and infinity. But other than that, they pretty much have everything in there. And so most of the set that we were giving in our problem will be inside our little bubble. So for the real numbers, we have negative 20, negative square root of 3, negative 1, 0, 0.25, 14 over 2, square root of 64, 2 over 6, 0 over 5, square root of 19, and pi. Basically everyone lives in the real numbers. So then we go to our last section, which is undefined. So which numbers are considered undefined? Basically anything when it's divided by 0. And so you can't divide by 0 because it's just not possible. It's not something, if you ever put it in your calculator, you'll just get an error message. So therefore dividing by 0 is undefined. So an undefined, all we're going to have is 1 over 0. Now, if you notice in the beginning, let me scroll up, we had, for example here, we had 14 over 2 be a natural number and a whole number. And the same thing for square root of 64. Then we had 0 be a whole number and an integer. And here we see again 14 over 2 and square root of 64. How is this possible? Well, we have, let me write in blue, we have our little number system. So we start off with natural numbers. And a natural number is also considered a whole number. And then a whole number and natural numbers are also considered integers. Because what are integers again? It's all the negative numbers and the positive numbers. And the positive numbers include whole numbers and natural numbers. And then we have here, we have rational numbers, which are a little fraction. They follow the fraction form. And then afterwards, here in a little bubble, we had irrational numbers. Finally, both irrational numbers and rational numbers live under the real number system. And so, but again, undefined was just out here on its own. I hope you guys enjoyed the video, and let us know if you have any questions.